part 1 was the foundation. Now part 2, this is where we really get tested. If you open any A-level maths paper and you look at the questions worth 7, 8, 9 marks, they are almost never pure power rules. They are chain rule inside of a product rule, inside of implicit differentiation. They're connected rate, they're differential equations, and therefore they are, without exception, from part 2. Which means if you watched part 1 and thought you were ready for the exam, you're not. You've got the grammar, but you don't have the language yet. So in the next 20 minutes, I'm going to give you the 7 rules that separate A-star students from everyone else. So let's get into it. Here's a question that trips up more students than any other in A-level maths. Differentiate y is equal to sine 3x squared. Most students will pattern match to what we spoke about in part 1 and write cos 3x squared. But that's wrong. And as a result, that's 3 marks gone. When a function sits inside another function, you can't just differentiate the outside and move on. The inside is doing the work too, and so the chain rule gives it credit. dy by dx is equal to dy by du times du by dx. So you differentiate the outer, leaving the inner alone. Then you multiply by the derivative of the inner, and that's it. For y is equal to sine 3x squared, our outer function here is sine, okay? So therefore its derivative is cosine 3x squared. However, the inner is 3x squared, so that derivative is 6x. And so according to the chain rule now, if we multiply, we get dy by dx is equal to 6x cosine 3x squared, okay, where the 6x is the chain rule paying respect to the inner function. Okay, and that's 3 marks that a lot of people can leave on the table. Here's one that the exam board loves. Differentiate y is equal to 2 to the x. Now it looks polynomial, but it isn't. Because the power rule doesn't apply here, but we don't need a new rule. 2 to the x is a chain rule problem just in disguise. What we're going to do is use the principle that a, okay, is going to equal e to the power of ln a. So therefore 2 to the x is going to equal e to the x ln 2. Now it's just e to the something. Chain rule, the outer stays, we multiply by the derivative of the inner. Ln 2 is a constant, so dy by dx is equal to e to the x ln 2 times ln 2. Which gives us what? Well, that gives us 2 to the x ln 2. And so that generalizes to the fact that d dx of a to the x is equal to a to the x ln a. The takeaway here is that the chain rule isn't just an advanced tool, it's the tool. Because every rule from here assumes you've got it locked in. The product rule assumes it, the quotient rule assumes it, implicit differentiation is it, just with a costume on. So if you walk away with only one thing from this video, make it this one. What's the derivative of x squared sine x? If your first response is to say 2x cosine x, then stop, because that is, again, similar to before, one of the most classic mistakes. You cannot differentiate a product by differentiating each piece separately, and there's a rule for this. And what is that rule? Well, that rule is what we call product rule, and that is if we have y is equal to uv with both u and v being functions of x, then dy by dx is equal to u times dv by dx plus v du by dx. In other words, uv dash plus v u dash, if you want to keep things, shorthand. Let's say that y is equal to x squared sine x. So we can let u equal x squared and v equals sine x. So therefore du by dx is equal to 2x and dv by dx is equal to cosine x. If we plug that in to our product rule equation, we get dy by dx is equal to x squared cosine x plus 2x sine x, which is not 2x cosine x. So if we take y is equal to x cubed times e to the 2x, our product rule says that u is going to equal x cubed, whilst v is going to equal e to the 2x. But remember, dv by dx, it's not e to the 2x. What is this? Well, this is a chain rule problem. Okay, so as a result, our derivative gives 2e to the 2x. So as a result, dy by dx is equal to 2x cubed e to the 2x plus 3x squared e to the 2x. Okay, and if we want to factorize that, we get x squared times e to the 2x times 2x plus 3. Now, students often panic about the quotient rule because they forget which term goes first, they mess up the signs, and they get the denominator wrong. But I'm going to show you why this panic is pointless. Because realistically, the quotient rule is just a product rule in disguise. And in an exam setting, really, if you want to be quick, you can just use the product rule. However, just for the purposes of illustration, I'll show you how this applies to some trig functions so you can see why those trig functions derivatives work the way they do. Alright, so the rule here, guys, is that if y is equal to u over v, then dy by dx is equal to v du by dx minus u times dv by dx over v squared. So let's say we have to differentiate y is equal to sec x. Okay, and sec x obviously isn't in the obvious toolbox that we're used to. But we know that sec x is simply equal to 1 over cosine x, which is a quotient. So from our rule here, we can say that u is equal to 1. Okay, so therefore du by dx is going to equal 0, okay, because u is a constant. Then we're going to let v equal cosine x, which means that dv by dx is going to equal negative sine x. Putting this all together then, dy by dx is equal to cosine x times 0 minus 1 times negative sine x. All of this over cos squared x. Okay, which equals sine x over cos squared x, which equals 1 over cos x times sine x over cos x, okay, which equals sec x times tan x. Let's imagine now that the exam gives you x squared plus xy plus y squared is equal to 7, and it asks for the gradient of the tangent at a point. You stare at it. Y isn't isolated. The variables are all tangled. So how do you differentiate this? Well, the answer to that is implicit differentiation, which, exactly as I said, is just the chain rule, but with a costume on. Every y in the equation is still a function of x. So whenever we differentiate a term with y in it, and we apply the chain rule, differentiate as normal, then multiply by dy by dx. Again, then we can solve for dy by dx at the end. Okay, so for x squared plus xy plus y squared is equal to 7, we're going to go term by term. So d dx of x squared is equal to 2x. And for d dx of xy, what we're going to use here is, you guessed it, the product rule. Okay, so if we let v is equal to y, therefore dv by dx, okay, it's going to equal dy by dx. Okay, so d dx xy is going to equal x dy by dx plus y. Next, d dx of y squared, well, this is a chain rule, okay, because we have the outer, which is squared, and the inner being y. Okay, so we're going to take the 2 down, so we get 2y, but we're not done yet because we still have to apply the chain rule to y. And when we do that with respect to dx, we get dy by dx, okay, so therefore 2y times dy by dx is going to be our final answer for this. Okay, now for the right side, which is just 7, this is pretty easy. We see d dx of 7, which is equal to 0. So if we assemble this all together now, we get 2x plus x dy by dx plus y plus 2y dy by dx is equal to 0. So we have an equation we can solve for, okay, where we need to isolate dy by dx because that's what we're solving for, and we'll get a proper equation here. Okay, so if we separate dy by dx here from everything else, we can say that dy by dx is equal to negative 2x plus y over x plus 2y. Now, one of the reasons why this is seen so much in the exam is because it tests everything at once. You've got the product rule, chain rule, algebra, and composure under pressure. Sometimes we get a situation where x and y are both defined by a third variable. So sometimes, maybe we're dealing with a variable t. And so we have x is equal to t squared and y is equal to 2t, for example. That's what's called parametric form. And so the rule for that is that dy by dx is equal to dy over dt divided by dx by dt. And you can see that that very simply simplifies down to dy by dx. If we take a worked example here, and we say x is equal to t squared plus 1 and y is equal to t cubed minus 2t, we can say that dx by dt is equal to 2t, whilst dy by dt is equal to 3t squared minus 2. So as a result, dy by dx is equal to 3t squared minus 2 over 2t. As a quick warning, sometimes they might ask for dy by dx in terms of x. So when that happens, okay, and you've got it in terms of t, we simply have to substitute it back. Okay, so we can take our x equals t squared in this example, sub that in, and then we can do the same thing for y is equal to 2t there, okay, and adjust accordingly for that to get it in terms of x. Now here's the final boss of nearly every exam paper. Let's say a question has 3 variables and a paragraph of a bunch of fluff that relates to the real world, and somewhere in the middle we've got a cone filling with water at 2 centimeters cubed per second. Now this looks confusing, but it actually isn't. What we're going to do here is actually just chain derivatives together, okay, and just substitute the variables according to our real world scenario. So for instance, we might get dA by dt that we need to find, change an area over time, and that's going to equal dA over dr, for instance, times dr over dt, where maybe r is the radius. So let's say that water is poured into a cone at 2 centimeters cubed per second, and we know that the cone is 10 centimeters tall with a radius of 5 centimeters. We are then told to find how fast the water level rises when the depth is 6 centimeters. So a few key clues here. First, how fast means we are finding something with relation to time, so hence dt, okay? And water level rises, that hints that we're working with height. So therefore we need to find dh by dt, specifically, okay, at h is equal to 6. Now we know also that dv by dt is equal to 2, and also that the volume of a cone is equal to 1/3 pi r squared times h. So what do we do from here? Well, volume is equal to 1/3 pi r squared times h. But utilizing the principle of similar triangles, we can say that r is equal to h over 2. So now r and h aren't independent. So as a result, we can say that v is equal to 1/3 pi h over 2 squared times h, which gives us pi h cubed over 12. And if we differentiate this now, we get dv by dh is equal to pi h squared over 4. Now at h is equal to 6, dv by dh is going to equal 9 pi. So if we combine this now, dh by dt is equal to dv by dt over dv by dh, which gives us 2 over 9 pi centimeters per second. So every connected rates question is the same question. You need to identify, chain, substitute, differentiate, solve, always in that order. Now what happens when we are told to describe things like population growth, radioactive decay, cooling? What does that entail? Well, that's all differential equations. Now what do we do when it comes to differential equations? Everyone gets scared about differential equations because they look so different, but really they're not. All we have to do is solve an equation via integrating, and that's basically it. So your job is to undo the derivative in the equation and get it back to the function. And the ones you're going to meet at A level are separable. So we're going to rearrange until every x is on one side and every y is on the other. And then we can integrate both sides independently. So if we are told to solve dy by dx is equal to xy, given that y equals 2 when x equals 0, what we're going to do here is we're going to separate first. So we get 1 over y dy on one side and x dx on the other. From here we can integrate, and when we do that we get ln y is equal to x squared over 2 plus c, but we have a condition. When x equals 0, y is equal to 2. So we apply the condition, that gives us c is equal to ln 2. Now if we turn that into a exponential function, all we're going to get is y is equal to 2e to the power of x squared over 2. To take everything we just covered and link it all together, the chain rule is the chain rule. The product rule needs the chain rule when inner functions are compounded. Quotient rule is just a product rule in disguise. Okay, so again, that's the chain rule. A to the x was the chain rule in disguise. Implicit differentiation is just the chain rule applied to y. Parametric differentiation is the chain rule when we have something like t as the bridge. Connected rates is the chain rule applied to time, okay, and reality. And differential equations use chain rule every time you integrate via substitution. But of course, this is all theoretical, so if you're keen to join a like-minded student platform and a community where you're all aiming for A's and A stars, make sure to click the link below if you are struggling with exam prep at the moment and you're looking for the most streamlined way possible to get an A or an A star.